Hi everyone. I hope this finds you doing well, staying safe, and staying healthy. I wanted to show some enhancements in Illuminated Cloud to the underlying JetBrains IDE's type inference capabilities in JavaScript and TypeScript. And I'm going to use that term interchangeably by just saying JavaScript. Mostly in Lightning Web Components, although as we get into the demo, I will show some of the ways that you can leverage some of the underlying mechanisms in other places where you implement things in TypeScript and JavaScript on the Salesforce platform, and even off of the platform, things like Salesforce functions. But the primary focus of this demo is going to be in Lightning Web Components. And I want to put one caveat out there at the beginning. Everything I'm about to show here is primarily accessible when you're using Illuminated Cloud with the commercial JetBrains IDE. So if you're using Illuminated Cloud with the free JetBrains IDE, one of the community edition IDEs, unfortunately the things I'm going to show are not going to be available to you as enhancements. The reason is that they actually augment the underlying JetBrains, commercial JetBrains IDEs, JavaScript and TypeScript language support capabilities. So just wanted to get that out there so there are no kind of missed expectations about what I'm showing here and whether it'll work or not in the underlying JetBrains IDE that you've paired Illuminated Cloud with. Okay, so to set the stage beyond that, JavaScript, I think, as everybody knows, is a dynamic language. And obviously, that's a beautiful thing in some ways. But one thing that it definitely misses as a result is type safety. There are ways to add type safety, at least to some extent or another, in JavaScript. And some derivatives, such as TypeScript, as indicated by its name, are built upon a stronger data typing mechanism. You know, typically when you define classes, types, things like that in TypeScript, you give them concrete types or even rather complex data types, but the type information's there. But when you're working in, for example, ES6, like you are like most people are, some people do use TypeScript, but most people are when they're doing Lightning Web Components development, there's not much in the way of type information. Now, having said that, in general, when you're working with the Salesforce APIs and the Salesforce modules and things like that, everything really does have a well-defined type. It's documented in their own API documentation, module documentation, but it's not reflected in those APIs. So that brings us to what I'm about to show is with these enhancements, Illuminated Cloud provides strong typing as much as it can. There may be other opportunities for improvement. We'll talk about those at the very end. But as much as I'm aware of and as much as I can, it can provide strong data types, strong typing in the type inference engine used by the IDE. And so the majority of the interaction that you do in JavaScript, Lightning Web Components JavaScript with the Salesforce platform begins with the importing of modules with this @Salesforce namespace prefix. You can pull in stuff about your schema, your objects and fields, static content references, basically URLs to things like content assets and static resources, your message catalog labels so that you can apply internationalization and localization to your user interface and to other messages, your permissions. So you can do dry run authorization of your user interface so that the UI is set up appropriately based upon what the user can and can't do. And it's not a reactive type of thing. You can proactively set up the UI that way. And then the ability to interact with more complex things like the various wire adapters for Salesforce feature sets like analytics and the database. The ability to invoke and interact with server-side logic implemented in Apex via R-enabled methods. So all these things start with imports. They start with importing of Salesforce-specific modules, and all of those things have a data type. So let's start with some of the simple things. Let's take a look at these, say basically down to the permissions, and just look at what they look like now with these enhancements in Illuminated Cloud. So things like your object IDs and field IDs, the benefits you're going to get, this is the goal, the benefits you're going to get from having better type information are going to be more narrow and accurate code completion and therefore quicker typing, quicker creation of your code, and improved static type analysis, specifically when it comes to things around data type, like type mismatch, unresolved symbols, whether a signature that you're trying to invoke actually exists based upon the provided parameters, things like that. So if we look at this object ID, we can see that the only code completion shown are going to be those that are applicable to this object. And so the ones that are in the darker type are going to be the first class fields of these objects. or methods. So object API name for an object ID, and for a field ID, field API name and object API name. And if I navigate into that, I can see that it has directly linked that to the correct module. And so we're going to get good code completions. We know that that's a string. So if I say dot, then you've got the string code completion. Similar down here with things that are imported to strings. So your URLs, your message catalog labels, it knows that they are strings. Things that are brought in as flags, as Booleans, I can even extract this out, this permission, and I can see that the inferred data type is in fact Boolean. So it's much smarter about that. But those are the simple examples. Let's look at some more complex examples. Why don't we start with bringing in some of the server-side logic via our enabled Apex. So let's look at some of these methods we're bringing in Apex. What you're seeing here is the Apex, not JavaScript, in this little quick info view. So we have several methods. We have one that returns a list of expenses. We have one that returns a single expense. Neither of those take, take parameters. We have one that takes a single expense, updates it, or upserts it, and returns the saved version of that expense. So we have inputs and outputs. And then we have one that returns not something like an SObject or a primitive, but actually an instance of an Apex custom data type, a data transfer object, where the expectation is that the serializable fields on that, in fact, get serialized to JSON, sent across the wire by the wire service, picked up, deserialized into a destructured object in JavaScript so that you could then refer to it. And so we'll take a look at each one of these in turn, or kind of speed through them. So we import get expenses as get expenses, and there are two primary ways that you can interact with Apex server-side functionality. You can use the wire service, and you can wire a local JavaScript function or a local JavaScript field, and it gets wired with a tuple effectively that is the data. If it was successful, the data ends up being the actual translated return type of that method that was invoked, and the error, which is the state information about that wire service invocation. So did it succeed? If it failed, error code, error message, things like that. And so wired into a method, you're going to end up getting this passed to you. It can either be a single object or a tuple that it has an error property and a data property. And these are now strongly typed. It knows that the translated return type of get expenses in Apex is, in JavaScript, an expense array. It knows that the error object is a fetch response object, and we can begin working with these in a first-class manner. If I hit dot, this is an array. You can see it showing the array methods. If we index into it, I can see the fields of the SObject. So for example, I can say amount, and we can chain these however we want. We say created by username. So where is that coming from? Well, if you're familiar with Illuminated Cloud and you're familiar with its offline symbol table, you know that a major aspect of that offline symbol table, so for example, if we look for amount here, account. How about we type the right thing? If we look for account here, we can see that it created an Apex class. This is not new. This has already existed. It created an Apex class called account, extends SObject, and it has basically the schema of your account object. All the fields, all the relationships. It integrates the actual Salesforce documentation for those things. So you can see field and object level documentation. Well, if we navigate into this, we can see it now does the exact same thing using TypeScript type definitions, one each for your SObjects. So we can see the expense object here. We can see standard objects like account, and we can see all their fields. And the same thing holds where we have the integrated API documentation. Same general functionality, but now the schema of those SObjects is made available as TypeScript type definitions that don't even have to be imported, are directly referenceable from within your JavaScript and TypeScript. And things like custom objects and fields that come from installed managed packages. It knows that they need to be namespace prefixed if the package has a namespace, all that. And so that's how we're able to work with these. And again, Illuminated Cloud is translating. Similarly, the fetch response here, it knows that it has certain properties. So we could actually get the status text if we wanted to show that. So you're seeing all the code completions, so that's certainly one of the benefits of type safety. But the other one that I mentioned is static code analysis, and we're not seeing that here, right? So I'm assigning a string to what should be a fetch response. I'm assigning a number to what should be an array of expenses, but we're not seeing that. And the reason is these are untyped fields. And so this becomes a small gap, and we'll look at, it's a gap between anything that uses these fields and the things that populate these fields, the assignments that happen with these fields. There's a gap in this type information. But we can, as developers, we can give some additional type hints to the IDE where Illuminated Cloud's not able to do it and the JetBrains IDEs are not able to do it through type inference. We can give additional type hints to bridge those gaps. Well, typically you would do that by creating a type hint, a doc-based type hint, and we'd say something like expense, and we can see that we've got nice code completion here on the type names, and we would go ahead and finish that, and now it knows that this is of type expense. But I've made that a lot easier. You can use a quick fix. So on Windows or Linux, it can be Alt-Enter. On Mac, it's going to be Opt-Enter. You can see it says Add Type Hint. It's going to add a JS doc-based type hint. Just hit Enter, and it'll fill it in and start you with completion on the data type. So we'll go ahead and do both of these real quick. Add Type Hint, and this is a fetch response. I'll fill that in. And if we go back down here, we can see that we now actually have some errors. It's saying that number is not assignable to an expense array. It's saying that string is not assignable to fetch response. So now we're getting that static code analysis, and we can go ahead and just take off the expression and have the assignments the way that they were, and that will go away. And now we know that we actually have things looking quite right. So that's good. Those are two improvements. Much more focused and accurate and useful code completions and some static code analysis. The idea is that you should be able to detect errors right here in the IDE that otherwise would have not been detected. Really, some maybe at the compilation phase after you've deployed, a lot of them because of the dynamic nature of the language, not until runtime. So to make things such that you can have a much higher level of confidence by the time you're running the code. Okay, so like I said, one way of doing this is wiring. Another way of getting to server-side Apex is via imperative Apex, where you call it directly but asynchronously via the promise pattern. And so it has automatically looked at the signatures of all of these methods that we brought in and determined what the correct promise signature should be. You can see that the IDs actually kind of provided inline hints for this. So it knows that get expenses is going to return a promise that when fulfilled gives the return payload, the list of expenses, and when it fails it gives a fetch response. Similar with get expense, we can see that this is all happening automatically. I have no type hints here. That's a single expense. Down here, it's save expense. It's a single expense, but we can also see that it knows about the inputs. If we had other parameters, it would show them here as part of the signature, and it knows that the params have to match the actual call signature of the auto-wired imported Apex method. And so now we have access to that. We can say result dot, and now we can get access to the fields, everything strongly typed. Let's look at the one that was a custom Apex type, an instance of a custom Apex type, that data transfer object. So we'll go ahead and go into that and take a look at that again. And so we'll go up here where we imported that and take a look at get DTO. And we can see that that has a lot of different fields that are being sent over, including one that's a recursive reference back to itself. And some are properties, some are fields. So let's go back over and look at what happens when we call that through imperative. So when we call that through imperative, it actually creates a destructure. It uses destructuring, JavaScript destructuring, to create effectively an anonymous object with the same schema as close as possible to the same schema. And so as close as possible means that where it can translate primitive types in Apex into the corresponding primitive types in JavaScript, it will do so. SObject types to SObject types, arrays to arrays, things like that. If it can't figure out what to do with it, it'll just use any. Now here's an example of an any, and the reason for this is it's a recursive field. And if you're familiar with destructuring, effectively a recursive field would create an infinitely deep destructured object, and so we can't do that. So it's just going to stub that as any, and then if you needed to work with that, you could obviously extract it into a variable and use a doc-based type hint in order to give that the correct type. But for the overwhelming majority of the time, you're going to get really nice code completion. If we said something like, instead of a count field, if we said something like contacts field 0 dot account, we'll say assistant name. So it's going to give really nice code completions based upon that. So that's imperative Apex. Same thing is going to hold for all these wire adapters. Some of these wire adapters are pretty complex. So like get pick list values. Let's go ahead and look at some pick list values. I have examples of all these, but I'm just going to go ahead and type this out. Wired pick list values dot, and now we have to go through data. Again, we get that tuple. So we have to go through that and data, and now we actually have our pick list, and we can say values 0 dot attributes dot default close. These are some of the specialized attributes available for some of the known pick lists like opportunity stage and things like that. But so you have all this as part of the available code completion. And it's not just here. You know, it's not just in JavaScript. We can go over to the HTML and all of these things complete properly now. So if we say wired record, which uses the record API to query a record, then we can get data and we can get the API name, the fields, the child relationships. So we're going to get the API name and we've got that. Similarly, it knows how to do things like loops. So there's data type inference from loop variables to the collection being used for the loop. So we'll do the two different types of loops. We'll do for each of expenses and we'll call our for item just E. Close that up, and then we can say now an expression e.amount, which is a field on amount. And similarly for the iterator template, we'll do iterator. We'll go ahead and call this one IT since that's the default. We'll go across expenses, and now we can say IT dot created by dot username. So you get the idea. Basically, it's going to make Lightning Web Components JavaScript development and the corresponding HTML when you're using braced expression significantly more type safe, significantly quicker because you're going to get accurate code completions, significantly higher confidence because you're going to see things like type mismatches. And I actually didn't show this, but we'll go back over here and you're also going to see if you mistype something. So if we take this out, that no longer, it's unresolvable, just like what Apex does when you have an unresolvable reference. And so now we know that we have a typo. If we type this ourselves or if we change something and it didn't propagate through a rename refactoring, we can see that there's a problem. This isn't going to compile on the server. And so very high confidence there. And like I said, this could be used in other or I shouldn't say other languages, other environments where you can use JavaScript and TypeScript. So let's go over to say Aura. And in Aura, we have a method called, let's actually create expense. And create expense gets past the component itself and an expense. And the expense in this case is of the type, the same schema as the SObject type expense. And so we've added a type hint here. In this case, because it's a call parameter, I'm not using add type, I'm using add expense. And now if we say expense dot and we've got the actual schema of it. And so maybe you're working with that in Aura, maybe you're working with that in Visual Force, doing single page app development via static resource based JavaScript. Maybe you're working with the schema of these objects in Salesforce functions in TypeScript or JavaScript. And you can just add type hints. One thing I just mentioned TypeScript in type hints, you would still want to do a type hint when you're doing these SObjects instead of making it strongly typed, like statically typed to that. And the reason is these SObjects are an Illuminated Cloud offline symbol table thing. And if you statically type them, then the TypeScript compiler is not going to find those, not going to be able to resolve those when it gets sent over to Salesforce. And it's going to result in a compilation failure. But you can still get the same IDE editor benefits by using those comment-based type hints. So pretty long little demo, but there's a lot here. And so I'm hoping that people will find this useful. If you've talked to me before, if you've seen my demos of functionality, if you've seen what I've done with Illuminated Cloud, you've probably recognized that I'm a strong proponent of letting the IDE do as much of the heavy lifting as possible, whenever possible. And this is certainly an instance of that. There's a lot of type information, even in an untyped dynamic language. There's a lot of type information. It just needs to be added to the runtime or the editor environment so that it can be used and propagated. And that's exactly what Illuminated Cloud is doing here. I'm sure there are bugs. Let me know if you run into something. If there are other opportunities for adding type information that I've missed, I've tried to go up and down and scour their documentation and fill in those gaps. If there are things that I missed, let me know. I'll add them. My goal is completeness to the extent that it's possible here. And otherwise, just let me know what you think of this. And thank you very much for your time. And everybody, as I said at the beginning, stay healthy, stay safe. Take care. Bye.